Hello. Okay, so 5.5, this is the last section in our first part of chapter 5. And this is going to be all about laws of sines and cosines. So 5.5. All right, the last video was super short. I think it was like 8 minutes. Buckle up. This one's about to be long. So if you want to like go get a sandwich or a coffee or something, now's the time. Hit pause and come on back. So we're going to talk about law of sines first. And let me tell you when these are used. These are used, both of them, both are used to find missing sides or angles of non-right triangles. Okay. And so there's a time, here's when we're going to use the law of sines. We'll just kind of law of sines. If you have a triangle, let's say we have A and B and C. So this would be little a, little b, and little c. You're going to use law of sines when you have, I'm not sure the best way to denote this. Let me try this. I need a highlighter. Okay, so an angle and its opposite side, any one of them, A or B or C, but you have to have the angle and the missing side, and then either a missing angle or a missing side. Okay, so, but you have to have this corresponding angle and side, any of them, like I said. So, law of sines. So you must have an angle and side ratio, right? They go together. Big A, little a. Big A, big B, big little b. Big C, little c. And then another side or angle, doesn't matter which. Okay, that's when you would use law of sines. Law of cosines, because it's important that you know when you used which one. If we have A, B, and C, little a, little b, little c. Okay, this one is used when you have what's called two sides and an included angle. So two sides and the angle that's between them. Okay, so two sides and an included angle. So that's when these two sides and the angle that comes between them. That's when you use law of cosines. Okay, so you must have, there's actually two different ways you could use law of cosines, but this is one. Must have two sides and their included angle. Okay, and you could see, I mean, I hope you could see how that could be A and C with B included or B and C with A included, right? It could be any of those three combinations. Here's an or though. Or you have no angle and all three sides. Okay, that's the other time that you can use law of cosines. All right, so on the next couple screens, I'm going to give you the actual rule for the law of sines, and then I'll walk you through one example, and then I'll give you the rules for the law of cosines and walk you through two examples, because I want to do one like this where you have the two sides and the, oh, sorry, one like this where you have the two sides and the included angle, and then I want to do one like this where you have all three sides. Okay, so, all right, let's move along. So here is the rule for the law of sines. Okay, so you're going to have three ratios set equal to each other. A over sine of A is equal to B over the sine of B is equal to C over the sine of C. Now, I know in varsity, these are going to be set up with Greek letters. So the other way you want to think about this is A over the sine of alpha is equal to B over the sine of beta is equal to C over the sine of gamma. Okay? And so these are the same. These are equivalent statements to each other. Just one is using English letters, one is using Greek letters. All right? When you use these, you're going to use two of the three ratios to solve, and you need three of the four missing pieces. Okay, let me give you an example. And also, you should probably know that these are all set up in varsity as like solve the triangle. So you're going to have to find everything. But we'll start like this. Okay, so I'm going to draw myself a triangle. Ignore that little hunk at the top. And here's the problem. Given alpha equals 73 degrees and beta 87.3 degrees and little a equals 5, solve the triangle. Okay, so the first thing you're going to want to do is label stuff. And if you want to put in there English letters and put A, B, and C in there, just know that alpha's A and beta's B and whatever. But I'm going to label mine alpha, beta, and gamma, and then A and B and C. Okay, and I know alpha is 73, and I know beta is 87.3, and it really doesn't matter if these are to scale or not, you know. So then in varsity, what you're going to see, I'll use a different color over here, is alpha equals, beta equals, gamma equals, and then A equals, B equals, and C equals. Okay, so we know alpha is 73, beta is 87.3, and now you can go 180 minus 73 minus 87.3, and that's going to equal gamma, right? Our leftover angle. And I already did that math, and it is 19.7 degrees. I would expect you to check that on your own. Make sure these all have little degree symbols on them. We were told that A is 5, so we can plug that in here. And then our job is to find B and C. Now, on the previous screen, I said you've got to have an angle and its corresponding side. So we have alpha and A. We have angle beta, but we don't have B. So we're going to use these two pieces of this ratio. Okay, we know A, we know alpha, we don't know little b, but we do know beta. So we know three of the four. We don't know anything about C or gamma, so we can't use this. It's kind of off the table for this one because we just don't have any information. But we'll get there. We'll find it all. Okay, so I'm going to set this up and I'm going to say alpha. I'm going to use this right here. This is what I'm going to fill in down here. So I'm going to say alpha, or A, I'm sorry. So 5 over the sine of 73. Don't forget the sine. This is super important, and a lot of kids try to leave it off. You just cannot. Equals B, we don't know it, so I'm going to leave it a B, over the sine of 87.3. Okay, well, this is literally cross multiply and then divide. So you're going to cross multiply and divide. And you're solving for the unknown, right? So I'm going to take and multiply these two things, and I'm going to get b times the sine of 73 is equal to this times this. So 5 times the sine of 87.3. And don't do any math yet. Get the b all by itself before you do anything. So I'm going to take this side and divide by the sine of 73. Divide this side by the sine of 73. And then cross it out, cross it out. Okay, and you can quite literally go to, let me actually do this. I'm going to have to attach a keyboard. This may be a little bulky and take me a second, but I want to show you how you can stick that right into Desmos to get your answer. I haven't done much of that, but let's go back to here. I'll go to Desmos. Okay, so I would throw a fraction in there first, throw my fraction in, and I'm going to put in 5 times the sine of 87.3, right? Is that what we had? Yeah. Yep. 5 times the sine of 87.3. So 5 times is the asterisk. You can either type out or use the sine function right here. If you type it out, make sure you put a parenthesis. And then 87.3, I would make sure you physically close it. And then you can arrow down or click down there. And I'm putting the sine of 73 on the bottom. Sine of 73 on the bottom. Close the parenthesis, and you can see your answer over here. You get 5.222, blah, 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 blah. So I don't know what this problem said. Round to, I have 2 decimal places on my paper everywhere. So 5.22 would be my answer here. Okay, so we're going to flip back over here, and we're going to say B is 5.22. I had to disconnect my keyboard there, so bear with me a moment. All right, so B equals 5.22. Okay, and now sometimes people are like, well, I could do Pythagorean theorem. But keep in mind that you can only do Pythagorean theorem if you have a right triangle, and we do not. So you have to do law of sines again. And I would continue to use this A part because they gave you both pieces of that. So I would continue to use 5 over the sine of 73 is equal to, we know this angle right here is 19.7. So I would say C equals sine of 19.7. Now do your cross multiplication. So we're going to have 5 times the sine of 19.7 is equal to C times the sine of 73. And then we're going to divide both sides by the sine of 73. Sorry. And I've already done this math somewhere else. And C is equal to 1 point, oh no, yeah, 1.76. So this is 1.76. Okay, so let's talk about feasibility, okay, real quick. So this side is super small compared to the other two sides, which are pretty close together, right? Well, look at the size of these angles. This angle is really small compared to these two, which are not very different in size. 73 and 87, those are pretty close. These two sides that correlate them are pretty close. So biggest side or biggest angle, biggest side. Medium size angle, medium size side. And these two are pretty close in size, the angles, so are the sides. This is the smallest angle by a lot. This is the smallest side by a lot. And that will always happen, okay? If this is your biggest angle and this is not your biggest side, something is wrong in your math. You have done something wrong. So just pay attention to that because those things should always happen. The ratios should always be correct. Sides and angles should always happen like that. Okay? So that's all that's really involved in the law of sines. It's not really terribly difficult. Now we're going to go talk about law of cosines. Okay, so the law of cosines. And I'm going to flip back real quick here. We talked about this happening when you have two sides, and an included angle. And it can happen with all three of them. So I'm going to give you three formulas right off the bat over here. Okay, so here's one. A squared equals B squared, it's a B, B squared plus C squared minus 2BC times cosine of A. The next one is B squared equals A squared plus C squared minus 2AC times the cosine of B. And then C squared equals A squared plus B squared minus 2AB times the cosine of C. Okay, so how do you know which one to use? Well, you're going to pick the one that matches the angle that you're given. Okay, so if you're given angle B, you're going to pick this one. All right, you're just going to plug stuff in and find side B. That's essentially how it's going to work. All right. Um, if you are not given an angle, so if you're given all three sides, we're going to derive a formula that you can use, and I'm going to take this one here. Okay, so I'm going to take A squared equals B squared plus C squared minus 2BC times cosine of A. And we're going to solve it for cosine of A, essentially. All right, so I'm going to subtract off the B squared and the C squared. So I'm going to go A squared minus B squared minus C squared. That's going to be equal to negative 2BC times cosine A. Okay, well now I'm going to divide this side by negative 2BC. And you don't have to be able to reproduce this. I just want you to know where it's coming from. So this will cancel this and leave all of this equal to cosine A. Okay, well, if I'm trying to solve for an angle, what do? I go inverse cosine of all of this stuff, A squared minus B squared minus C squared over negative 2BC, and that's going to be equal to angle A. Okay, so you can use this formula if you are given all three sides and no angles. And make sure it's a non-right triangle, right? That's important. So, law of cosines. If you're given an angle, so use one of these if given an angle. And then if you're not given an angle, you're given all three sides, you're going to use this formula down here that we just derived, okay? And it's literally coming from this right here. We just took it, moved things around, divided by stuff, and you're solving for A. Okay, so that's the beginning. What we're going to do now is solve a couple problems. Here we go. So let's put this in black, example, if alpha equals 106 degrees, B, equals 38, and C equals 40. Solve the triangle. Well, you're not going to know what you have until you actually draw yourself a picture. So we're going to draw a picture. I like to draw those kind of triangles. I'm going to put alpha down here, beta up there, gamma here, which means this is A, this is B, Sorry. And this is C. Okay, and we know alpha is 106, B is 38, and C is 40. So here you can see, grab a highlighter, this two sides and the included angle, right? That's what we got right there. Two sides and an included angle. So that says law of cosines. That's how you know what you're using if the problem doesn't say use the law of cosines to solve this problem. That's how you know, okay? So, and I told you to pick the one, go back to this screen, pick the one to match the angle you're given. Well, we're given alpha, which is A, so we're going to use this first one here, okay? So we're going to write that thing down, which is A squared equals B squared plus C squared minus 2BC times the cosine of A or alpha. And then we're going to plug in what we know, okay? So we know. We don't know A squared. We know B is 38, so 38 squared plus C is 40 squared minus 2 times 38 times 40. And this is a times cosine of 106. Okay, so these things, and this is important, this is where a lot of people go wrong here. These things are all getting multiplied together. Negative 2 times 38 times 40 times cosine of 106, okay? You can technically throw all of this into Desmos and get an answer to that, but you also might want to do these numbers separately, 38 squared, 40 squared, get a number for this thing squared. I'm not going to do that. I'm going to give you a whole big number just to save some space on my screen, okay? So I have a squared equals 3881.937562. Okay. So I don't know if you know how to use the answer button in Desmos. If you don't by this time, you probably should come talk to me and find out how to use that. But you can take and put onto your screen, you need to take the root of a squared, right? And then we're going to take the root of this big long number. And don't round these numbers before you put these in here. Don't round until you get to an answer. Okay, so we're going to get, I would put into Desmos, I would put the square root of the answer, because then that'll use this whole number and plop it down in here for you. And you're going to get A is equal to 62.3. Okay, and so that is here, 62.3. And now from there, this is where this gets a little bit simpler, because if you recognize it, from here, you can now switch to law of sines, because now I have A, and I have any side, B or C, and I can use law of sines. So, and that's quicker and easier and just so much faster. So I'm going to switch to A time over the sine of alpha is equal to, I'm going to do B over the sine of beta. I'm going to fill those in. So I'm going to go 62.3 over the sine of 106 is equal to 38 over the sine of beta. Okay. And then when I move that over here and I cross multiply, I'm going to get 62.3 times the sine of beta is equal to 38 times the sine of 106. Forgot the 1. And then I'm going to divide by the 62.3. Whoops. 62.3. So this will cancel here, leaving me the sine of beta. And if you do this math, 38 times the sine of 106, make sure that's all in your numerator, divided by 62.3, you should get the number 0 point, some little decimal, 5863233,458. And when you get something like that and you're like, that doesn't seem right, don't forget that you're looking for an angle, right? And when you're looking for an angle, you need to hit your inverse sine button. So you're going to go inverse sine of the answer. So that'll put that in there. And then you're going to get beta is equal to 35.9 degrees. And that's beta. Okay, so this is 35.9. And now all you have to do is go 180 minus 106 minus 35.9. And that's going to equal gamma, which is 38.1 degrees. Okay, so now we know this guy. We have all three angles and we have all three sides. Okay, so that's how you would do one of those problems. Now, here's the way you would use it if you're given all three sides. So here's an example. Okay, so if A equals 11, B equals 13, and C equals 18, find alpha, beta, and gamma. Okay, so this should tip you off immediately. It'll also say something like in a non-right triangle. I'm just not wasting my time writing that, but this should tip you off immediately that we have a law of cosine situation. I'm going to label these alpha, beta, gamma. A equals 11, B equals 13, and C equals 18. Okay, so now I'm going to flip back to this formula that we derived a couple screens ago down here in blue. Okay, I have it on my paper as well. So when I write it down, don't be like, I don't know where that's coming from. All right, that's where it's coming from. So we're going to use that when we have all three sides, no angles. So we're going to find angle A, and that's going to be equal to the inverse cosine of A squared minus B squared minus C squared over negative 2BC. Okay, so we're just going to plop stuff in there. So A is going to equal the inverse cosine of 11 squared minus 13 squared minus 18 squared all over negative 2 times 13 times 18. And when you do these, I would highly recommend that you get a number for this and get a number for this separately. And there's a reason that I would recommend you do that. When you do that here, you get a negative 372 over a negative 468. And just going back to right triangle trig, here's kind of a note, something you should be aware of. It's super important. It happens in sine and cosine. Okay, so sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Well, what's the longest side of a triangle? You know, it's the hypotenuse, right? So this has to be longer than the opposite or the adjacent, right? It has to be bigger. It has to be longer. So if you do one of these problems and you end up with a number up here that's bigger than the number down here, you have a problem, okay? That can't happen. And if it does, and you're sure that your math is correct, then you have a triangle that does not exist. So if the numerator is greater than the denominator, and I'm not talking in terms of signs, not like absolute value of the numerator over the absolute value of the denominator. So it doesn't matter if they're positive or negative. Okay, so If the numerator is greater than the denominator, and you're sure your math is right, like check it a couple times, then the triangle, I hate when these little boxes show up. The triangle does not exist. And it's very likely that the answers in varsity are therefore D and E. And I know that there's at least one problem where that happens. It's not this problem because this one, the numerator is smaller than the denominator. So that's good. Okay. But if that's why I would do these separate. Just take your time, do the math, make sure of what those numbers are. Okay. And if I put those in, I now put in inverse cosine, and in the parentheses, in my inverse cosine, I put negative 372 over negative 468. I get A equals 37.4 degrees. Oops, I was going to put 34.7. Hold on. 30, I need an eraser. 37.4. Okay, so that's this guy. So 37.4. And now we can go back and do law of sines. Since I have this diagonal, I can do that. So I'm going to go little a, 11 over the sine of 37.4 is equal to b over the sine of b. So I have b over the sine of b. And then I'm going to go 11 times the sine of b is equal to 13 times the sine 37.4. And then I'm going to divide both sides by 11. That'll cancel that. And then I'm going to go inverse sine, right? Inverse sine of 13 times sine 37.4 over 11. And when I do that, I get B or beta is equal to 45.9. Okay. And then, the last step, I'm going to go 180 minus 45.9 minus 37.4. And that's going to give me my gamma, which is equal to, I don't know that I finished that on my paper. That's funny. I'll let you figure that out. No, I have it on my paper, 96.7. 96.7 degrees. So I have that. I have this. I have this. And we already knew the other ones. Okay? So that's how you're going to utilize that if you find that you only have three sides. All right, and that is your law of sines and cosines. We are going to get ready for a chapter test and then move into some more ambiguous trig with your unit circle. So toodaloo for now.